These sounds have been known to humans for centuries, but no one knew what they meant. We thought they were just the sound of the ocean. It turns out they're a language. A complex communication system of ocean giants that artificial intelligence has just decoded. What you just heard are the first words in the language of sperm whales that we've finally learned to understand. To understand the magnitude of this discovery, imagine this. You walk into a theater, sit down, the lights go down, the curtain rises, and the actors on stage begin speaking in a completely unknown language. You hear the tone of voice, you see the emotion, you understand that something important is happening, but the meaning is completely beyond you. This is exactly how humanity has listened to the ocean for millions of years. Until the 1970s, whale sounds seemed to sailors like mysterious sounds from the depths of the sea, beautiful and mysterious, but completely incomprehensible. In the 19th century, whalers hunted sperm whales for their oil, which was used in lamps, unaware that they were killing amazing creatures capable of complex communication. It turns out that sperm whales are the loudest animals in the world. Their clicks can reach 200 decibels, much louder than a rock concert or the roar of a jet taking off. But until recently, no one knew they made any sounds at all. That changed in the early 1970s when marine biologist Roger Payne made a discovery that shocked the world. Payne recorded the songs of humpback whales and released the album Humpback Whale Songs. The album became a cultural phenomenon. People heard whales sing hours-long, complex, and haunting melodies that changed over time like live music. The public's reaction was immediate and powerful. The Save the Whales movement was launched, leading to the passage of the Marine Mammal Protection Act in the United States, and saving several whale species from complete extinction. All of this happened just because people heard their sounds. Roger Payne later said, "I realized that people had fallen in love with whale sounds. Imagine what would happen when we understood what they were saying." But at the time, no one knew what these loud noises meant. Scientists speculated. Perhaps they were mating songs, alarm calls, simple signals of food and danger. The technology was primitive, the recordings short and of poor quality, and most importantly, the context was absent. We would hear individual phrases without knowing the context in which they were said. The problem transcended technical limitations. We tried to understand whales through human reasoning. But what if their way of communicating was completely different from ours? What if we had no idea what these giant sea creatures were really capable of? In 2017, a meeting took place at Harvard University that changed everything. Marine biologist David Gruber was examining recordings of sperm whales. From the office next door, Turing Award-winning cryptographer Chaffee Goldwasser heard the clicking sounds. They reminded him of Morse code. Goldwasser suggested using machine learning to decode sounds. She introduced him to David Michael Bronstein, an AI specialist at Oxford who was working on early versions of large-scale language models. Bronstein explained an important principle. To understand a language, AI needs massive amounts of data. Applying these techniques to whales would require billions of recordings of their vocalizations, complete with context. At first, this seemed impossible, but Gruber realized it was exactly what could be done. Gruber had another idea that initially sounded crazy. He was collaborating with the CETI project, the search for signals from extraterrestrial civilizations. For decades, astronomers have been scanning the universe in the hope of receiving a message from extraterrestrial beings. But what if we're looking in the wrong place? What if here on Earth, besides us, are there intelligent beings with whom we can communicate? Sperm whales have the largest brains of any animal, averaging 7 to 9 kilograms, 6 times the size of a human brain. They live in complex social groups, passing their knowledge from generation to generation, and have cultural traditions. If we received a signal from an extraterrestrial civilization, we would need the technology to decode it. So why not train on whales? In 2019, these 3 scientists returned to Harvard for a 2-day symposium. It brought together biologists, roboticists, linguists, and machine learning specialists from around the world. By the end of the second day, it was clear to everyone, decoding sperm whale language was indeed possible. Thus, CETI, the Cetacean Translation Initiative, was born in 2020. TED Audacious provided $33 million for 5 years of research. The team consists of 50 leading scientists from 15 institutions around the world, including MIT, Harvard, Oxford, Berkeley, and the National Geographic Society. Gruber assembled a unique team. Daniela Rus, director of the MIT Artificial Intelligence Lab; Shane Giro, a marine biologist who has studied the same sperm whale families off the coast of Dominica for 15 years; Robert Wood, a soft robotics pioneer from Harvard University, and several others. They chose the Caribbean island of Dominica for the experiment. The location is unique. Volcanic cliffs drop so steeply into the sea that the deep sea begins just a few hundred meters from the shore. The sperm whales can get very close to land, making them accessible for observation. And crucially, the same families return year after year. The team transformed a stretch of ocean near Dominica into a massive underwater recording studio. A system of dozens of hydrophones operates around the clock, creating an acoustic map of the area in real time. When a sperm whale emits a series of clicks, and the system instantly identifies which whale in the group is speaking. But audio recordings are only one piece of the puzzle. To understand a language, we need context. Who is speaking to whom, in what situation, and what emotions are involved? This is where robots come in. The CETI project has developed a fleet of autonomous drones that follow whales and carefully attach biosensor tags to their backs. The team studied how marine animals cling to each other in the wild and developed biologically inspired attachments so sensitive that the whales barely notice them. These tags are technological marvels. They record not only sounds but also the whale's 3D movements, their dive depth, their heart rate, and precise information about the other animals they are currently interacting with. Each tag can operate for up to 3 days. But how do you find a whale in the vast ocean? Sperm whales spend only 10 minutes per hour at the surface, diving to depths of 5 kilometers the rest of the time in search of squid. In 2024, the CETI project unveiled a revolutionary system called avatars, which consists of AI-controlled drones that have learned to predict whale behavior. These drones receive signals from transmitters on whales and pinpoint their location with astonishing accuracy. A machine learning algorithm analyzes the whale's behavior patterns, the duration of their dives, the direction they move underwater, and the sounds they make, and predicts where they will surface. The accuracy of this algorithm is astonishing. 80% of the time, the drone is in exactly the right place when the whale surfaces, even if it is hundreds of meters from its dive point. In 5 years, the CETI project has created the largest library of marine mammal sounds ever. Billions of individual sperm whale clicks with a complete behavioral context. But the sheer volume of data presented a new challenge. The human brain is physically incapable of processing such a huge data set. This is where the real magic of AI begins. All sounds are converted into spectrograms, visual maps where each click becomes a colorful pattern on the screen. AI can see the sounds and recognize patterns imperceptible to humans. Neural networks were trained on billions of examples, gradually identifying structure in what previously seemed like chaos. The results exceeded all expectations. What we once thought were random clicking sounds turned out to be a highly organized communication system. Sperm whales use codas, short rhythmic click sequences that function like words in the human language. Each coda consists of a specific number of clicks with precise time intervals between them. For example, a common coda among Caribbean sperm whales is 1 + 1 + 3. 1 click, pause, another click, pause, then 3 rapid clicks in succession. In May 2024, the CETI project team published a groundbreaking study in the journal Nature Communications. By analyzing 8,719 symbols recorded off the coast of Dominica, the AI identified 156 distinct basic patterns. But that was just the beginning. Each symbol can vary in several parameters, creating a myriad of unique words. The first level is speed. The same symbol can be moved slowly or quickly, changing its meaning accordingly. The second level is additional clicking sounds at the beginning or end, similar to suffixes in our words. The third level turned out to be the most surprising. Whales can slightly lengthen or shorten the pauses between clicking sounds, just as we change the pitch of our voice to express emotion. The fourth level is subtle time variations that function like vowels in human speech. Whales use subtle time variations to convey different types of information. We discovered a 2-level compositional system similar to human language, explains Jakob Andreas of MIT. The lower level consists of the sounds that form words. The upper level consists of the words that combine to form sentences. However, the most surprising findings relate to cultural differences. It turns out that different sperm whale clans, their family groups, use different dialects. These aren't just different symbols, but different ways of applying them. The team found that clans with overlapping territories adopt elements of each other's vocalizations. This is the first evidence of social language learning in a marine mammal. The AI also learned to identify the individual vocal characteristics of specific whales. Each animal has a unique signature in the vocalization of symbols, small but consistent. Differences in timing and rhythm that allow it to be identified among hundreds of other whales. Imagine being able to distinguish a particular whale's voice as easily as you would a friend's voice on the phone. In addition, the system can track how a whale's vocalizations change with age and what new elements it adopts from its family. The AI also discovered a surprising feature of learning in young sperm whales. Not only do sperm whales simply copy the sounds of their adult pods, they experiment with symbols and create new sound combinations. Some of these emergent innovations are adopted by other members of the pod and become part of the local dialect. In short, we are witnessing the instantaneous evolution of language. Sperm whale language is alive and evolving, just like human language. But what does it all mean? Scientists have begun matching sounds with whale behavior. Shenjiro has identified several types of messages. There are social communication symbols, which whales use when meeting at the surface to exchange greetings and information about their well-being. There are coordination codes, used by families to organize joint hunts or movement in a specific direction. There are nursing codes, used by mothers to communicate with their young. Particularly interesting are the codes whales use before diving into the deep sea. AI has found several different dive codes, each with its own nuances. This means that whales don't just say, "I'm diving," but something more specific. "I'm going north to catch squid." "I'm diving deep. I'll be back in 2 hours." The analysis revealed something interesting. If a whale emits a particular code before diving, it will actually dive exactly where it announced it would. This means the system can predict what the whale will do based on the announcement alone. Even more surprising are the cases where information has been transmitted over long distances. Hydrophones recorded cases where a family of sperm whales off the coast of Dominica received a series of codes from relatives in other parts of the Caribbean, hundreds of kilometers away. Within hours of these long-distance calls, the entire group would change direction or behavior as if they had received important information. In one instance, the group abruptly changed course after receiving a series of signals from afar. It was later discovered that the area they were originally headed to was the site of a naval sonar exercise. In other words, another group had warned them of a potential danger. All the while, the team of scientists was preparing for the main experiment. If we understood the structure of their language, could we not only listen, but also speak? The first attempts at two-way communication began in 2023. The whale CETI team off the coast of Alaska studied humpback whales. Using an underwater loudspeaker, they played a communication signal recorded from a humpback whale. The response was immediate and astonishing. A female humpback whale named Twain swam toward the boat and began circling it, responding to each signal. The dialogue lasted 20 minutes, a true exchange of phrases between a human and a whale. Twain accurately copied the breaks between the signals, adhering to the rules of conversation. This discovery astonished the entire CETI team. That same year, 2023, they conducted their own experiments off the coast of Dominica. A diver, using an underwater loudspeaker, played one of the sperm whale ciphers they had been studying. A nearby whale responded with similar ciphers. Another exchange of signals followed. It was a humbling but historic moment, the first attempt to communicate with a sperm whale in its own language. In 2024, the team conducted a series of more complex experiments. Artificial intelligence analyzed the whale's responses in real time and suggested appropriate ciphers for the researchers to continue the conversation. Some dialogues lasted up to half an hour. The whales began to behave strangely. They began making sounds they had never made before around humans, apparently to communicate with each other about these strange bipedal, talking creatures. Occasionally, other whales joined in, leading to all-out group discussions. David Gruber describes the team's feelings. It was as if we were receiving the first radio signal from an alien civilization, except that the aliens had been here on Earth and lived alongside us for millions of years. But what exactly happens during these conversations? The team can't yet fully explain the content of the conversations, but the behavior of the sea giants offers some clues. Whales often use greeting symbols to begin communication, then move on to more complex sequences that may include questions like, "Who are you?" or "What are you doing in our waters?" The reaction of the calves is particularly interesting. Sperm whales. Their calves often swim closer to the source of a sound, showing curiosity about unusual individuals speaking their language. The team also observed that the whales changed their behavior in the presence of researchers. Some families of these giant pelagic whales spent more time at the surface when CETI boats were nearby, as if waiting for the conversation to continue. These observations have raised serious ethical questions among scientists. Do we have the right to interfere with the communication of another intelligent species? CETI, in collaboration with the Moth program at New York University, is investigating the legal and ethical aspects of interspecies communication. If we can prove that whales have a complex language and culture, will their legal status change? All CETI experiments are conducted with extreme caution. The team's principle: even if the experiment fails, the whales must not be harmed. If the animal shows no interest in communicating, the scientists do not continue. Still, the views are breathtaking. Prototypes of whale language interpretation devices are currently under development. Imagine a diver wearing a mask that reads, "Sperm whale says, 'Beware, there are predators here.'" The impact of the CETI project extends far beyond marine biology. The methods developed to decode sperm whale language are already being applied to other species. Thanks to this project, within 10 years we will be able to communicate not only with whales, but with most of the planet's super-intelligent animals. However, the most exciting prospects lie in the search for extraterrestrial intelligence. David Gruber repeatedly emphasizes, if we received a signal from space tomorrow, we would use the same algorithms we use with whales today. Finding patterns in incomprehensible signals, identifying recurring elements, and guessing their meaning. This is how any unknown language is decoded. Whether terrestrial or space-based, whales have become our training ground before we encounter cosmic intelligence. In 2024, the CETI project team launched a self-learning system of robotic gliders. Artificial intelligence automatically determines when and where to conduct observations, analyzing whale behavior, weather conditions, and ocean currents. Operating around the clock, the system uses satellite data to track the movements of whale families throughout the Caribbean. The results have exceeded all expectations. The quality and quantity of data collected tripled. In 2024 alone, the system recorded more than 1 million new symbols, including previously unknown communication patterns. One of the most notable discoveries relates to the intergenerational transmission of knowledge. The AI discovered that older females, the matriarchs of the family, use special teaching symbols when interacting with younger whales. These sounds are characterized by a slow tempo and multiple repetitions, as if grandmothers were patiently explaining important life lessons to their grandchildren. The analysis revealed that the young whales that received this training demonstrated more complex communication skills and improved hunting abilities. In short, we are observing a learning system among marine mammals. Even more surprising is the sperm whale's ability to reason abstractly. In several cases, the whales used new combinations of known symbols to describe previously unknown situations. For example, when an unknown technical object appeared in the water, the family emitted a unique series of sounds combining the symbols unknown and danger. The team also observed that whales, similar to humans, like to talk about past events. It turned out that certain sounds were emitted more frequently several hours after significant events. Sperm whales generate events, such as encounters with other families, successful hunting trips, or encounters with humans. This means that sperm whales not only react to current events, but also analyze past experiences, share memories, and plan their future actions. Therefore, their intelligence is closer in complexity to that of humans. The CETI project has also discovered how climate change affects whale communication. Due to rising ocean temperatures and water pollution, sounds are being transmitted differently. Whales have taken notice and have begun to speak more loudly, slightly modifying their vocal codes to adapt to the new conditions. The team observed that whales make special sounds when they see ships. It turns out that these sounds tell us the size of the vessel, its direction of travel, and its speed. Therefore, they have their own warning system for marine traffic. Scientists are convinced that sperm whales monitor human activities as closely as we study them. They may have their own theories about human behavior and their own names for our ships and technologies. The CETI project plans to develop the first fully audio interpreter for cetacean communication. In 2025 and 2026, the system will not only recognize the symbols, but will also generate them according to the rules of whale language. Imagine the moment when a human asks a sperm whale a complex question for the first time and receives a meaningful answer. What will we ask? About its life in the ocean? How does it see the world? What does it think of humans? And perhaps most importantly, what questions will it ask us? What do these ancient sea creatures want to know about a young species that, in just a few centuries, has severely polluted its habitat and nearly destroyed it? Perhaps the most significant change is what is taking place in our perception of ourselves. For centuries, we considered intelligence a uniquely human trait. Now we know that we share the planet with other thinking beings with their own language, culture, traditions, and history. Sperm whales pass on their knowledge from generation to generation for millions of years. Their cultural traditions predate human civilization. They have a history we are only beginning to discover, and they seem to know things about our world that we don't. Roger Payne, who introduced the world to whale songs and died in 2023, left his final words to the project. 50 years ago, humans fell in love with the songs of humpback whales and joined forces to create a global conservation movement. It's time to listen to whales again, this time with all our compassion and creativity to understand them. We are on the cusp of a new era. For the first time in human history, We can hear and respond to the voice of another intelligent species. But are we ready for a dialogue that could forever change our understanding of intelligence, consciousness, and our place in the universe?